equation, we are given two circles intersect at 2 points B and C. Through B, a line ABD is drawn such that it intersects the two circles at point A and D, and also a line PBQ is drawn such that it intersects the two circles at points P and Q. We have to prove that angle ACP is equal to angle QCD. That is, we have to show that this angle is equal to this angle. Before beginning with the solution, first let us name the angles. Let this angle be 1, this be 2, this be denoted by 3, this by 4, and the angle we have to find, let us denote it by 5, and angle PCD by angle 6, and the angle C, this angle, that is angle DCQ by angle 7. Now in the smaller circle, notice that the arc BC subtend angle 1 and angle 2 in the same segment of the circle. Arc BC subtends angle 1 and angle 2 in the same segment of a circle. This implies that angle 1 is equal to angle 2, since we know that angle subtended by the same arc in the same segment of a circle are equal. So this implies angle 1 is equal to angle 2. Also for the bigger circle, notice that arc BC subtend angle 3 and angle 4. This implies that angle 3 is equal to angle 4, since arc BC subtends angle 3 and angle 4 in the same segment of the bigger circle. So this implies angle 3 is equal to angle 4, and reason being the same, since the angles subtended by the same arc in the same segment of a circle are equal. Now we know that sum of three angles of a triangle is equal to 180 degrees. This implies in triangle ACD, sum of angle DAC, that is angle 4, plus angle ACD, which is the sum of angle 5 and 6, plus angle CDA, which is angle 2, is equal to 180 degrees. And also in triangle PCQ, we have angle P, that is angle 3, plus angle PCQ, which is the sum of angle 6 and 7. Sorry, this is angle plus angle Q, which is angle 1, is equal to 180 degrees. Now let us denote this equation by 1 and this by 2. Now from 1 and 2, since the right hand sides are equal, therefore the left hand sides are also equal. So angle 4 plus angle 5 plus angle 6 plus angle 2 is equal to angle 3 plus angle 6 plus angle 7 plus angle 1. Now angle 6 cancels out with angle 6, and angle 3 is equal to angle 4 and angle 1 is equal to angle 2. So Here writing angle 3 in place of angle 4 plus angle 5 plus angle 2 is equal to angle 3 plus angle 7 and angle 1 is equal to angle 2. Now again cancelling common angles from both the sides. We have angle 5 is equal to angle 7 and this is what we are required to show, which can also be written as angle ACP is equal to angle QCD. Hence our answer is angle ACP is equal to angle QCD. This completes the solution.